welcome to chemistry class. Today we're going to learn about chemical reactions and the energy involved with those. So to start off, I'm going to show a little video, and this is a pretty amazing explosion. So,
Ooh, I like it.
Is it an atom bomb?
no, so this balloon is filled with hydrogen and oxygen in very strategic combinations, and they added a catalyst to it.
Yeah.
So they added a catalyst to it to make it go off on its own.
Oh. We're gonna do that
Okay.
later.
Not quite, I wish. That would be super cool, but not quite.
Dangerous.
So in that reaction, there was a lot of energy that was released. There's a lot. So we're gonna do, first off, I need you guys to get into 4 groups. So I'll let you guys decide on what groups you want to be in.
Yeah.
Okay.
Just
Group?
so you two,
I'll just be by myself.
you can hop in another group. We'll have
Oh, okay.
a group of 3. So
I'll join you guys.
you 2, you 3, and you 2? Yep, perfect. Okay, so the first thing I want you to do is just talk about energy and what we talked about last time. What do you, discuss energy and what you think is involved with energy, heat, how is it released, what happens in chemical reactions, just kind of what you think will happen.
Energy cannot be created.
You're a smart guy. Come on.
Wow, thanks for that.
I will beat you up after school.
I think
Come on.
it's merely a
Energy.
transfer of energy.
Energy creates
What?
heat.
No, I don't think so.
What do you
No, I don't
There's like
remember.
little mechanism things that create energy.
Endothermic
Like
Lab.
shoots out.
In or
It's
that.
not
It's really good. I like
And we
that.
learned last time in
Yeah.
class that energy was neither
What did you guys
created
come
nor
up with?
destroyed.
No.
Energy.
That's
That's a
what
good
that's
point.
what
Who said that? You made
That's
that.
what teacher
That's
taught
what
us.
You made that up.
That's what Miss
Yeah.
This is
Mercer
always
taught
I'm
us.
having a dream or something.
You totally made that up.
Awesome. Alrighty, guys.
Don't you?
So we're gonna go ahead and we're gonna do some labs to explore energy released and absorbed in reactions. Okay. So there's a lab sheet for you. There's a lab sheet for you guys. There's
Does that mean I'm a
pens
team
right
leader?
here.
No.
You only need to fill out 1 worksheet per group. So if
I'm a
2
bully.
of you or somebody wants to start on the hand warmers and some on the baking soda.
What do we do?
Just a second. I gotta grab the.
Warm them with your hands.
They're already warm.
Well, they are? No, they're not.
Yeah.
You want to see how it Have you guys ever seen it?
Oh,
Was
don't
this
do
the
it,
one?
don't
Is this
do
the
it.
one with
So for the
okay.
baking
This
soda
one
and the
with
vinegar,
coin in
who's
it?
doing that?
We can do it.
Wait, do it.
Oh,
Wait, can I crack that?
Wait.
Hold on.
You're
Read the directions. Read the directions.
Reverse.
Okay, so this one is gonna be about halfway down.
It's like crystal form before you crack it.
Red.
Yes. It feels like jelly.
Wait, what are we doing?
We're doing the baking soda.
No,
Sure. Which one are we doing?
Whichever one you want to start with. It
We
doesn't
start
matter.
with the hand warmer?
Yes. Start with the hand warmers.
Okay, record your
Okay, so
observations.
we're gonna do
Green.
the half teaspoon of baking
What is
soda
the texture?
to a full teaspoon of.
Jelly. Put
Vinegar.
jelly.
Jelly's not a texture, that's a type of teaspoon.
It's
Just
jelly.
one. You guys do okay?
Oh yeah. Yes.
Yeah.
What is the temperature? It's room temperature?
More than higher than room temperature.
Snap it? Yeah.
Slightly.
They're slightly warm.
I've never actually watched.
Okay, so now it's like crystallizing.
And that's hot.
Snap the metal button.
No
in the
wonder you
hand
never
warmer.
freeze with all of these.
Snap it. Snap it.
Wait, should we say one for these guys?
Oh, yeah.
Yeah.
Okay,
Okay.
save one for this group.
one?
Oh,
Okay.
Snap it.
Yeah.
Snap it.
Save one there.
How do I snap it?
Like that. Pop it. Like.
snap. Yeah. just
actually, like,
literally
snap
snap,
it.
that.
It didn't snap.
No, it is because it's
Fine.
crystallizing.
Whoa, what is happening?
Mix it
It's
up
getting
real
hot.
good.
It is
reacting.
Wow, it's like energy's coming out.
Ow,
Wait.
Be really
So record your observations.
It's really hot.
Crystallized.
Awesome.
It's so hot it hurts.
Became so hot.
Does it hurt?
Ow,
What did you guys find out? Taylor, Scott, and Abo, what did you guys find out?
We finally got hotter.
You got hot?
You got
Good.
hurt.
Good.
There you go.
Smells like Easter eggs.
Wait, I'm holding it.
Awesome.
Guys, I want to hold it too. Guys, Matt, something hold it.
So it got colder.
Both of
This.
us.
Anything else?
That was a very fast reaction.
What's the next?
Actually,
Are you guys ready for the
energy is
baking
often
soda and
produced
vinegar?
after you snap the button,
Almost.
the hand will release energy from the feet.
What did you guys
The energy of the
notice?
system of the
Increase.
universe. The energy does increase, decrease, or stay the same. Or the energy of the universe. The
Yeah,
energy of the
good.
system
It did get cold.
decreases because it lost energy.
Yeah, 'cause now it's hotter out here.
How does it take?
That's a great question.
This one
Is it a lower energy level? And so in order to get
So
to
energy of the
other
system
energy,
decreased.
it takes
The
all the
energy
heat
of the
from other
universe
surroundings it wants to-
increased.
Okay.
What the?
Taking our heat.
Yeah.
Okay. That's pretty cool. Okay.
So when you're done with that, you can move on to the hand warmer.
with the one.
It's not very
Are you guys done with the hand warmer one?
Nope. No,
Is
they
it
were
cup?
done. We were done.
Okay.
Baking soda.
Now take a cup of
And then-
vinegar.
Pour it into soda bicarbonate baking soda.
Okay,
So,
Nah, bro.
wait, so we put the baking soda in first.
I think so, yeah. How much baking
Well,
soda did you
I
put
was gonna
in?
do Dixie cups, but I didn't have them. So baking soda, you're gonna put a half teaspoon, and then you're gonna put a full teaspoon of vinegar.
Gotcha.
Hey teacher, do you have any sodium hypobromite?
Yes, in the stock room, but we're not going to pull that one out today.
Oh my gosh, it's spreading. Oh, what do we do?
Hey teacher, ask me if I have any sodium hypobromite.
Do you have any sodium hypobromite?
Nah, bro.
That was a good one.
He's really funny.
That was
Never
a good
heard
one.
that one.
Hey Matt,
So what
I
is
saw
it?
this
What's
girl
happening?
who's really good at singing songs.
Feel the bottom side of your
And
cup.
her songs are really
Pretty
good.
warm?
Yeah.
Whoa!
More solid.
Oh my gosh.
Whoa, balls!
Exothermic
Okay,
Lab.
what
What, are we supposed to touch it?
Guess
I
it's
don't know.
reverse the way you touch
Oh,
it.
fill the
No,
bottom.
put your
Taste it,
fingers in
taste it,
it.
taste it, taste it.
No, don't drink it.
Oh.
Probably not a great idea.
Nah.
Although
You
it
guys ever
does turn to
wondered-
water, but
Have you guys ever wondered what would happen if you drank a bottle of Coca-Cola and then put a Mentos in your throat?
It explodes.
Is it really?
Well, the one
Can we
way
do
to
that?
find out.
That's what I'll show you what I did
Yeah,
for
you might be able to do
Independence Day.
volcanoes out of Mentos and Pepsi. That would be fun.
Alright, so
And
what
it
happens?
wouldn't.
volcanoes.
So-
Just-
What happened?
I think the Lumo and the baking soda was impacted by the home bubble.
Oh, what is this vinegar?
What did you guys find
Acetic
out?
acid.
It bubbled.
It bubbled? Good.
Started to bubble.
That's
It did bubble.
right?
I think it's has
Oh,
What
yeah.
else happened?
What else happened, guys? I don't know.
Let's
Did you get cold?
carbonate.
Did you get cold?
From what I hear, like you actually
Shot?
Put some more vinegar in it and see.
Yeah.
Right.
Drink it!
Do you want to grab a napkin?
Yeah,
I will. It's fine. It's just water. Oh.
Is it?
Wait. It's just water.
I could have
You
drank
didn't
it.
use vinegar? I did, but
It turns into
It
water.
turns into
when
water.
vinegar mixes with baking soda, it reacts and it makes water.
So cool.
So now we
Now
know
we
we
can
can
drink
So technically,
You're not that.
can, but it's not in the right. It's not in quite the right
Let's show the
proportions because when I poured vinegar in
Oh
there.
yeah, it releases
It
water
would-
and carbon dioxide. That's what it smells.
Did anybody
That's
feel
wrong.
the
Eureka!
cup? It got colder.
Okay, let's see here.
Yeah, it did. It got colder.
Change texture.
Did it?
What are the
What's
what's
the
the
mass?
stomach reaction?
What's the next question?
The energy of the system
We were doing
increases.
before, but
So the
Does it
energy
feel like more solid?
of the system.
they would be the same.
How do you know?
It was
So I guess
It
I
got
got
colder, so it absorbed energy.
Why is that? Why is that? Why is that?
Manufacturing.
Because if it releases energy, you feel heat.
Do you guys have a
If it
question?
absorbs energy, you feel
Yes.
it.
You don't understand number
Number
6.
six. Okay.
So if you have different masses,
And the energy of the universe
but they would still be different.
equals. Oh, not colder.
Okay.
The existence increases.
So in this
The
one,
energy of the system colder.
so they're before the reaction,
Yeah.
it would have weighed different
Okay.
less after the reaction.
Right.
It would have weighed less after the reaction.
Because the crystals expand. The system increased.
Okay.
But this,
Good thought. Good thought.
That's what I was like. But this feels heavier than it
Which would
did.
increase buoyancy.
Oh really?
Okay.
Yeah.
And,
It's a good thought.
Endo.
Because it's
But
not
this feels
existing.
heavier than it
It's
did.
endo.
It's
It's
yeah.
in
So
there.
you're asking to
And-
release.
So what I want
I'm
you to
pretty
do,
sure
I want you to make
endothermic Comes
your
from
best
Latin
guess
root.
based on what you know about energy and mass and
Endo
conservation
means
laws that you
inside,
were talking
actually.
about
If
earlier.
we were able to measure the mass,
Make a guess, and we're going to come back and talk about that.
we would have found that they were
Exact same
different
thing
before the
after.
reactions took place,
Okay.
the reactions
So,
after the reactions took place.
do you guys have any questions?
It was
Because
converted
if it
into
were
energy.
inside, it has to steal it.
Really?
Is it
Scott
Yeah,
thinks
I
he
see the
knows.
mass.
I
At
don't
least for
think
these
anything.
that
He
you
thinks he knows what he's talking
this,
about.
like, I feel like you lost some.
Right, what?
Yeah, because it
Hang on,
there's
that's the big
gas.
soda and
Yes.
the we talked about.
You lost it in the baking soda, and it went into
Not
the
into their mass.
environment, the world.
Well, some of the
Things
letters
that they
carbon
did
dioxide.
Yeah.
Did it?
Yeah, that's
I
carbon
Carbon
dioxide.
dioxide is a
Yeah,
byproduct.
based on this test.
What about you guys? Are you guys good? Have any questions or?
He's smart.
On that one, so it probably.
Smart guy.
This is so nice.
Bonus question!
Whoa.
Extra credit.
Singular hand warmers. At the end of the reaction are the products at a lower energy, higher energy, or the same energy. So energy before the reaction started.
That's a hard one.
Uh-oh.
Well, it released energy, so they're
What
lower.
happened to the mass?
After?
Some of it evaporated in the form of gas.
And the end of the reaction of the products. Yes, they're in a lower.
Yep.
That's why when you boil it, then it goes
Does it
back.
say why?
Tricky.
Yeah.
We'll see.
And then wait, what about the mass of the hand warmers? Why did that?
Think about the hand warmers at the end of the
What's the
reaction.
mass of that? Is hand warmers
Lower
change?
energy,
It's the
higher
same.
energy are the same.
I don't think any got out.
So,
Like change,
Think of instead of hand warmers, think of burning wood. That's a better example than hand warmers. Because some of the wood goes away, it gets burned, and then you have less. The charcoals are smaller, right?
Is it the same thing as releases gas?
Okay.
So yeah, that's a better example than that.
So gas leak.
Alrighty, is everybody done with the worksheet
Up here.
and the labs?
Yeah.
Sure. What's the answers? Okay, so last time in class we talked about the conservation of energy and conservation of mass. I heard that a little bit when you were in your groups talking about energy. So who wants to say what they remember about the conservation laws? Scott?
What?
What were the conservation laws that we talked about last time in class?
That you can neither create nor destroy energy.
Okay,
It's
good.
just transferred.
Awesome. Perfect. What about matter? Renee, what about matter?
Ooh.
You cannot create it or destroy it.
Okay, good. Mass is conserved in chemical reactions. Mass is conserved. So with that, okay, the hand warmers on the worksheet was a bad example. If we had burning wood, so we talked about mass is conserved, but what about when you burn a piece of wood? That's a combustion reaction. It's a chemical reaction. Similar things happen. It puts off heat, kind of like the hand warmers did. But there's an obvious loss of mass. Where did it go?
The air.
Okay, good. To the air and smoke.
Gas.
And as a gas.
That was a gas.
Good. Matter can also, energy and matter can change forms. That's why how energy can be released. So, endothermic and exothermic. Those are kind of some new terms for you guys. Endothermic means on the outside, right? Endo is on the outside. So that's releasing heat. So which one of the reactions that you played with is an endothermic reaction?
Endo or exo?
Under?
Just kidding. Endo's inside. Endo's inside. Okay, so endo's inside and it's absorbing heat. Which one absorbed heat?
The sodium.
Good, because it got cold, right? So it took the heat from your hands and from the air, and it wanted it. So it took that heat away and it felt cold. Exo means on the outside. And so an exothermic reaction, what would that do? How would the energy be transferred in that? It's released. Good, and it's released as heat. What are some examples of this in the real world? How have you seen this in your lives? Endothermic or exothermic reactions?
Wood.
Yeah, campfires.
Burning wood.
Good. Anything else?
Can't use the example sheet.
Could you also say like the video you showed us?
Yeah, that was an
Probably a little
exothermic
bit.
reaction.
Very quick.
That's a good one.
It still released a lot of
Ice.
energy, right? Ice,
That's so good.
Ice
Kind of.
melting.
if it's melting.
Oh,
Also,
yeah,
if
so-
you mix salt with ice, it gets colder, right? That's how you
You
make
can
ice
burn
cream.
your skin.
Speaking from
That too,
experience,
but
What?
Burn your skin.
Yeah, that's what happened. It was
Feel good?
Emily, put your phone away. during
Sorry,
class,
teacher.
please.
Sorry,
Remember-
Mrs. Rogers.
Remember the rules.
Sorry, Miss Rogers.
Okay, good. Combustion reactions. Okay, going back to the firewood, those are exothermic reactions. Did you guys know that that's what happens when you eat food? Your body, the way it processes it, it's a combustion reaction, so it's exothermic. So, does anybody have any questions about what we've gone over? Anything that is still confusing to you guys? Aside from how endothermic reactions feel cold.
Can I go to the bathroom?
So I guess like in an exothermic reaction, is it always in the form of heat?
Usually, but not always.
Okay. I guess would there be an example of like when it's not heat? Or?
I'm trying to think. I think usually it's heat. That's a common way that energy is. That's a common way that energy is released. So, good question. Any other questions?
Alright, go for it.
No? All right. Well, if you guys want to take the last 5 minutes and finish your homework, great. Thank you.
Thanks.
Yay!